All right, good morning, everybody, and welcome to IGTV. And we have William H. Murray on with the InfraGard Editorial this week. And Bill, you're going to be talking about security architecture today?
I am, yes.
All right, well, this is one you're going to take me to the shed on, probably one of my weaker areas, unfortunately. All right, so without further ado, go ahead, Bill, get into it.
Well, first I want you to take note of my new ISC squared tie. Came this morning, and since I am no longer an officer, I can only assume that they just wanted me to look good on TV.
Well, it's a shameless plug, so, there's a lot of that going on here, and, we certainly wouldn't hold that against you at all. It's a beautiful tie, by the way. Maybe if the folks at IC Square are listening, they'd send me one. All right, Security Architecture 101, here we go.
And it is 101. I'd like to recommend to you some principles for security architecture. That is, how to design security into your enterprise, networks, systems, and applications. First, I have to say a little bit about architecture in general and security architecture in particular. Architecture is part of design. It is that part of design that deals with appearance, how things look, function, what they do, location, where they are, particularly where they are relative to the environment and to one another, and finally, materials, what they're built with. I like to use the analogy of residential architecture because that's what most of us think about when we talk about architecture. The design describes what the house will look like, what kinds of rooms it will have, where they will be relative to one another, and what materials the house will be built with. Note that the design of the house includes multiple views and documents, including sometimes a model, an elevation or a perspective, a floor plan, and a list of materials and their specifications. Most of the materials that are going to be used can be specified simply by reference. The architect reaches around and he takes down his AIA manual and he lists off materials that are already in there. Every now and then, he's going to have to talk about a purpose-built material, and that's going to have to be specified in detail. Security architecture deals with how security looks to the user. Security functions, such as user identification and authentication, access control and encryption, where the functions are located, and how they interact, and what components, both off-the-shelf and purpose-built, they're going to be composed of. My mentor, Harry DeMaio, likes to say that security architecture is derivative of and dependent upon IT architecture. But he then goes on to point out that if the IT architecture is not rigorous and well documented, then often we have to start by doing that. My own experience is that when I ask management for the description of their IT architecture, what I get back is a list of components, like we use Windows 7, we use SSL, but they rarely talk about where those things are located and how they are, what they're used for, and how they're related to one another. The implication is that much of the design is ad hoc, not to say it grew like Topsy. Thus, our work often starts with documenting what is, so that we can go on to talk about what will be. We speak of expressing the design. Like the design of the house, our design involves multiple views and levels of detail, multiple documents and models. We think of it as top-down, one page at a time, carefully indexed and cross-referenced. But as the designer of the building or house uses blueprints, we still call them that, though they're no longer blue. We use things like network diagrams, stack diagrams, and access path schematics. As the building designer uses pictures, we may use screenshots. As he uses models, we may use working prototypes. Design is an iterative process that begins with identification and documentation of requirements. Think about the residential architect. He needs to know something about the neighborhood, the family size, the lifestyle, taste, budget, etc. We need to know industry, business, strategy, environment, including natural and man-made hazards, scale, required behavior, forbidden behavior, permissible and impermissible failure modes, applications, risk tolerance, cost to overcome resistance, strength, organization, users, etc. Identifying and expressing security requirements is a topic for another day. In the meantime, I have posted in the chat a link to a paper that goes on to discuss security requirements in some detail. To identify all of these requirements, like the residential architect, we may use our experience, structured interviews, questionnaires, document reviews, and straw man documents, sample deliverables that illustrate design options and choices. For security design, these choices may include economy of logon, single point of administration, end-to-end user app, etc., etc., etc. So much for content. Let's go to the principles. First, practices, then appearance, function, materials, and finally, one or two ideas on sources. The most important practice, perhaps the most important design principle, is do it right. Do it right the first time. Build for the ages as contrasted to iteratively assess and fix. Design top-down by functional decomposition and iterative refinement. Plan to implement by composition from the bottom up. Prefer broad solutions, for example, backup, that works across the enterprise, across multiple applications, and that address multiple hazards and risks. Prefer end-to-end encryption-based solutions that are independent of the underlying network. Appearance. Provide a consistent presentation and interface that is predictable, intuitive, and obvious as to intent and effect. Designed for ease of safe use, such that doing the right thing is easier than doing the wrong thing. Hide and encapsulate necessary special knowledge, such as encryption keys. Using the system safely should require as little user effort and special knowledge as possible. Prefer simplicity, hide complexity. Design around roles and responsibilities so that users see only that which is relevant to what they are supposed to be doing. All other things equal, security should look the same across the enterprise. That is, across applications, systems, and platforms. Correct behavior learned in one context should not cause errors in another. Location. Place controls close to the resources, for example, on the server, but place operation of the controls close to the special knowledge required for its safe operation. For example, the control for enrolling users should be in the hands of the user's manager, while that for granting access to resources should be in the hands of the owner or manager of the resource. Place control where the localized function and place control where the effect of the operation can be observed. The operator of a control should be able to observe the effect of its operation. That's why we drive cars by feedback, right? Prefer functions and data only as prefer localized function and data. The fewer things that must operate correctly in order to get the safe result, the better. Distribute functions and data only to the extent required for reliability, accessibility, availability, and performance. Separate controls from their use and user. For example, the operating system of a server should be hidden from users of the server. Include audit trail in your design. An audit trail should enable you to know the current state of the system, how it got that way, and what it looked like at any specified point in the past. It should enable one to fix accountability for all use, content, and behavior of the system to the level of a single individual. Localize your security function. Prefer single services for naming of resources, users, and groups, authenticating users, and controlling access across a domain, for example, a network or organization. Similarly, prefer a single service for encrypting data and managing keys. Structure and layer your networks. For example, the public layer, peer with the internet and the public switch telephone network. A private layer for user and application work. A trusted layer, that is, trusted system to trusted system. And finally, a control layer, one for privileged operators to system controls. Isolate the layers from one another using firewalls, proxies, and encryption. For example, VLANs and VPNs. Prefer short segments and limited segment-to-segment traffic. And obviously that one's a trade-off, a balance. Prefer robust materials from trusted sources in tamper-evident packaging. Prefer materials that have been evaluated by third parties against industry or government standards. Prefer single-use to multiple-use components. Prefer hardware to software for process-to-process isolation. Prefer virtual machine to virtual machine isolation to operating system process to operating system process isolation. Said another way, place more reliance on hypervisor than the operating systems. Prefer industry standard, public, and mature encryption mechanisms and products. For example, SSL, SSH, IPsec, and avoid roll your own. That brings us back to do it right. Use the right material for the application. Use materials as they are intended to be used. Do not bend to fit. Do not break interfaces. That is, do not exploit knowledge that you may have about what is behind the interface. Now, you might think that this is a lot to absorb at one time. I guess it really is. On the other hand, once enumerated, the principles are pretty straightforward. Many of them you abide by much of the time without thinking about them. For those of us who participate in the design of organizations, networks, applications, or products, these principles can go a long way to earning us the warrant of professional and the big bucks that go with it. See you next week.